Hey, hi students, welcome once again to Dr. Saurabh Sir's classes. Today we are back again with another video on group theory, and you already know that we were doing parts on group theory. We have already completed so many parts, so many videos on group theory. Alright, and we are ready to continue on with the next part in group theory. In the previous video we had done two parts. If I go back to what we had done, I have it right in front of me. We spoke about equivalence class, and I taught you how not equivalence class, I'm sorry, equivalence relation, and how I taught you how something can be equivalence relation, and you already knew that, so that was not something new for you to understand how equivalence relation works, but how it works on groups, and how a right congruency modulo H is required, and how a left congruency modulo is happening. Alright, so we have learned quite a lot then in the previous video, and then we moved on to a few remarks where how H can be okay, a non-empty subset, how H could have been a how H could have been a subgroup, right? How H can be a subgroup. Okay, there were 2 points. The 2 points are given over here. It was already marked in the previous video. So moving on to our topic for today will be some important points on subgroup, students. Okay, I want to give you some vital points on subgroup. So you might want to take out your pen and your notebook and note down what is happening. So the first option says is that if H and K are subgroups, so if H is a subset of G and K is also a subset of G, then of course H comma K are subgroups of G, subgroups of G. That implies HK, that is the multiplication, HK is a subgroup of G. HK is a subgroup of G only when this condition is satisfied. What is the condition? HK is equal to KH. When this condition is satisfied, then HK, then this HK is a subgroup. Alright, students, moving on to our next point. It says for any two subgroups H and K, that means H and K are subsets, that means H and K are both subgroups also, a subgroup of G, then H intersection K is a subgroup of G if Y, if H is a subset of K or K is a subset of H. Now a very vital point, okay, you might want to mark this as important, very vital point. What does it say? There are two subgroups. They are already subgroups. H is a subgroup of G, S small g of G, okay, and K is also a subgroup, S small g of G. So both of them are subgroups of G. If both of them are subgroups of G, then H intersection K will also be an SG of G. When this happens, but that is of course if and only if. Okay, IFF means if and only if H is a subset of K and K is a subset of H. That means actually if any one of them happens, okay, both of them doesn't have to happen. Either this will be a subset of that or K will be a subset of H. Alright, so very important, two important points, students. I want you to mark both of them as important. These 2 points are absolutely vital for you to understand how things are going to be subgroups. Okay, we are talking a lot about subgroups. You must understand that a subgroup always follows the same rules as the group. Okay, but and also there are a few conditions. where it's going to be a subgroup. Moving on to Lagrange's theorem, another important point, students, marking it important. Lagrange's theorem. The order of any subgroup of a finite group divides the order of the group. Understand? What does it mean? The order of any group, the order of any group of a finite group, the order of any group of finite, sorry about that, my system was causing a problem, so please don't get angry with me. So Lagrange's theorem says that the order of any subgroup, SG, order of any subgroup of a finite group. Okay, there is a subgroup, say H, and it is a subgroup SG of a group G which is finite. Make sure you understand this, okay? It is finite, alright. The group G is finite. So the order of H will be, what will happen with the order of H? The order of H, the order of any subgroup of finite group divides the order of the group. So it will be like this: order of the group by the order of any subgroup, that is order of the subgroup H. So this is what will happen. Okay, all right, very simple logic, but very important logics. Okay, now look at this next point, another important one. Okay, these last points are really getting important. I don't know why, but they are. Actually, everything is important in this group theory. You know, if you see, what happens is, when you are in class 11 and 12, okay, when you are in class 11 and basically in class 12, if you have gone through the chapter of sets and relations and mappings and functions properly, then this type of talk or these things that I'm explaining to you is absolutely simple for you. Not getting very difficult. It's not very difficult to understand. But you see, if you have not studied the sets very carefully and you found it like, okay, you know, this is very boring and I can read this chapter, I don't think in the long run, you know, students have a tendency of saying that, you know, what will happen if I study the chapter integration? It's not going to help me in the long run. But eventually, if you are wanting to go ahead with mathematics, to study anything with mathematics, there are a few chapters that will continue on into higher classes. So if it continues on into higher classes, it's better that you go through it in the junior classes, so that in the higher classes the burden becomes relatively less. Okay, so I would expect that all of you students watching these videos are already familiar and thorough with chapters like sets, okay, relations, mapping. So then it becomes very easy for you. Now look, let's go on to the fourth point. Lot of chit chat. If H and K are finite subgroups of G, then order of HK is equal to what? Order of H into order of K divided by order of H intersection K. Please note down this. This is some type of a formula. I would expect you to note this down. In fact, you can note down everything that's been done. So let's go ahead and see what we had done in this series of videos, because I would like to show you. We had started with what we were going to do with group theory, and I showed you what we were going to do. We had some important points: subgroups, equivalence relation on groups, remarks. Okay, some beautiful remarks. Okay, these were the points we were going to do, right? And we moved on to the next one, that was the important points. We had done everything. I explained onto you everything. Then we moved on to a mathematical example where I gave you an example how to solve, okay, how the order of the element is infinite and it's not coming finite. Then we learned about subgroups, and we learned how Z plus is a subgroup of Q plus is a subgroup of R plus, and R plus, real numbers with plus operation, is a subgroup of complex number with addition operation. That also we have learned. Then we moved on to equivalence relations, students, like we did in class 12, reflexive, symmetric and transitive. That is how a equivalence relation, but in group it's a little bit different, a little twist than it happens with the right hand modulo. Okay, right hand congruency and the left congruency modulo H. Okay, and the sets are given to you already. Then we moved on to some remarks how H can be a subset, okay, of G. All right, then we moved on to some important points on subgroup. Okay, and that was the last of it. Okay, there was nothing more beyond this we did in this part of group theory. Okay, so I would expect you students to study really hard. Okay, make use of your time, make the best of your time. All right, students, and take as much help as possible from Saurabh classes. Go through these videos. The more you go through these videos, the more you refer to your friends, the more help they get, because all the help that you will be needing will be provided here at Saurabh classes. Thank you for watching, students. We'll continue this in the next video. Bye bye.